Amber is fossilized tree resin, which has been appreciated for its color and natural beauty since Neolithic times. Much valued from antiquity to the present as a gemstone, amber is made into a variety of decorative objects. Amber is used as an ingredient in perfumes, as a healing agent in folk medicine, and as jewelry. There are 5 classes of amber, defined on the basis of their chemical constituents. Because it originates as a soft, sticky tree resin, amber sometimes contains animal and plant material as inclusions. Amber occurring in coal seams is also called resinite, and the term ambrite is applied to that found specifically within New Zealand coal seams. History and names. The English word amber derives from Arabic iabao to the first uol plus or minus, Middle Latin ambar and Middle French ambre. The word was adopted in Middle English in the 14th century as referring to what is now known as ambergris, solid waxy substance derived from the sperm whale. In the Romance languages, the sense of the word had come to be extended to Baltic amber from as early as the late 13th century, at first called white or yellow amber for disambiguation, and this meaning was adopted in English by the early 15th century. As the use of ambergris waned, this became the main sense of the word. The two substances conceivably became associated or confused because they both were found washed up on beaches. Ambergris is less dense than water and floats, whereas amber is less dense than stone, but too dense to float. The classical name for amber was electrum, connected to a term for the beaming sun, a 1/4 per mil I. According to the myth, when 4-ton son of Helios was killed, his mourning sisters became poplars, and their tears became the origin of electrum, amber. Amber is discussed by Theophrastus in the 4th century BC, and again by Pythagoras, whose work on the ocean is lost, but was referenced by Pliny the Elder, according to whose The Natural History. Pythagoras says that the Geutones, a people of Germany, inhabit the shores of an estuary of the ocean called Mentonemon, their territory extending a distance of 6,000 stadia. That, at one day's sail from this territory, is the Isle of Abylos, upon the shores of which, amber is thrown up by the waves in spring, it being an excretion of the sea in a concrete form. Also, that the inhabitants use this amber by way of fuel, and sell it to their neighbors, the Teutones. Earlier Pliny says that a large island of 3 days' sail from the Scythian coast called Bolsia by Xenophon of Lampsacus, author of a fanciful travel book in Greek, is called Basilia by Pythagoras. It is generally understood to be the same as Abylos. Based on the amber, the island could have been Heligoland, Zealand, the shores of Bay of Gdansk, the Sambia Peninsula or the Curonian Lagoon, which were historically the richest sources of amber in northern Europe. It is assumed that there were well-established trade routes for amber connecting the Baltic with the Mediterranean. Pliny states explicitly that the Germans export amber to Pannonia, from where it was traded further abroad by the Veneti. Pliny also cites the opinion of Nicias, according to whom amber is a liquid produced by the rays of the sun. And that these rays, at the moment of the sun's setting, striking with the greatest force upon the surface of the soil, leave upon it an unctuous sweat, which is carried off by the tides of the ocean, and thrown up upon the shores of Germany. Besides the fanciful explanations according to which amber is produced by the sun, Pliny cites opinions that are well aware of its origin in tree resin, citing the native Latin name of succinum. Amber is produced from a marrow discharged by trees belonging to the pine genus, like gum from the cherry, and resin from the ordinary pine. It is a liquid at first, which issues forth in considerable quantities, and is gradually hardened. Our forefathers, too, were of opinion that it is the juice of a tree, and for this reason gave it the name of succinum, and one great proof that it is the produce of a tree of the pine genus, is the fact that it emits a pine-like smell when rubbed, and that it burns, when ignited, with the odor and appearance of torch pine wood. He also states that amber is also found in Egypt and in India, and he even refers to the electrostatic properties of amber, by saying that in Syria the women make the whorls of their spindles of this substance, and give it the name of harpax, from a 1/4 euro I paragraph I per mil, to drag from the circumstance that it attracts leaves towards it, chaff, and the light fringe of tissues. Pliny says that the German name of amber was glassum, for which reason the Romans, when Germanicus Khazar commanded the fleet in those parts, gave to one of these islands the name of Glasaria, which by the barbarians was known as Ostaravia. This is confirmed by the recorded Old High German Glas and Old English Glaya for amber. In Middle Low German, amber was known as Bern, Barn, bar paragraph Rnstan. The Low German term became dominant also in High German by the 18th century, thus modern German Bernstein besides Dutch Barnstein. Heated above 200 degrees Celsius, amber suffers decomposition, yielding an oil of amber, and leaving a black residue which is known as amber colophony, or amber pitch. When dissolved in oil of turpentine or in linseed oil this forms amber varnish, or amber lac. The Baltic-Lithuanian term for amber is jantaras and Latvian zintas. They, and the Slavic jantar or Hungarian gyanta, are thought to originate from Phoenician janata. Early in the 19th century, the first reports of amber from North America came from discoveries in New Jersey along Crosswicks Creek near Trenton, at Camden, and near Woodbury. Legends. The origins of Baltic amber are associated with the Lithuanian legend about Eurata, the Queen of the Sea, who fell in love with Kastytis, a fisherman. According to one of the versions, her jealous father punished his daughter by destroying her amber palace and changing her into sea foam. The pieces of the Eurata, a Euro unregistered trademark S palace can still be found on the Baltic shore. See also Jarata, and Kastytis. Composition and formation. Amber is heterogeneous in composition, but consists of several resinous bodies more or less soluble in alcohol, ether and chloroform, associated with an insoluble bituminous substance. Amber is a macromolecule by free radical polymerization of several precursors in the labdane family, for example communic acid, communal, and biformen. These labdanes are diterpenes and trienes, equipping the organic skeleton with 3 alkane groups for polymerization. As amber matures over the years, more polymerization takes place as well as isomerization reactions, cross-linking and cyclization. Formation, molecular polymerization, resulting from high pressures and temperatures produced by overlying sediment, transforms the resin first in a copal. Sustained heat and pressure drives off terpenes and results in the formation of amber. First, the starting resin must be resistant to decay. Many trees produce resin, but in the majority of cases this deposit is broken down by physical and biological process. Exposure to sunlight, rain, and temperate extremes tends to disintegrate resin, and the process is assisted by microorganisms such as bacteria and fungi. For resin to survive long enough to become amber, it must be resistant to such forces or be produced under conditions that exclude them. Botanical origin. Fossil resins from Europe fall into 2 categories, the famous Baltic ambers and another that resembles the agathis group. Fossil resins from the Americas and Africa are closely related to the modern genus Hymenaea, while Baltic ambers are thought to be fossil resins from Cyabopites hyacinae family plants that used to live in North Europe. Conclusions. The abnormal development of resin has been called succinosis. Impurities are quite often present, especially when the resin dropped onto the ground, so that the material may be useless except for varnish making, whence the impure amber is called gneiss. Enclosures of pyrites may give a bluish color to amber. The so-called black amber is only a kind of jet. Bony amber owes its cloudy opacity to minute bubbles in the interior of the resin. In darkly clouded and even opaque amber, inclusions can be imaged using high-energy, high-contrast, high-resolution X-rays. Extraction and processing, distribution and mining. Amber is globally distributed, mainly in rocks of Cretaceous age or younger. Historically, the Samland coast west of Karl-Paragraph-Nigsburg in Prussia was the world's leading source of amber. About 90% of the world's extractable amber is still located in that area, which became the Kaliningrad Oblast of Russia in 1946. Pieces of amber torn from the sea floor are cast up by the waves, and collected by hand, dredging, or diving. Elsewhere, amber is mined, both in open works and underground galleries. Then nodules of blue earth have to be removed and an opaque crust must be cleaned off, which can be done in revolving barrels containing sand and water. Erosion removes this crust from sea-worn amber. Caribbean amber, especially Dominican blue amber, is mined through bell pitting, which is dangerous due to the risk of tunnel collapse. Treatment: the Vienna amber factories, which use pale amber to manufacture pipes and other smoking tools, turn it on a lathe and polish it with whitening and water or with rotten stone and oil. The final luster is given by friction with flannel. When gradually heated in an oil bath, amber becomes soft and flexible. Two pieces of amber may be united by smearing the surfaces with linseed oil, heating them, and then pressing them together while hot. Cloudy amber may be clarified in an oil bath, as the oil fills the numerous pores to which the turbidity is due. Small fragments, formerly thrown away or used only for varnish, are now used on a large scale in the formation of amberoid, or pressed amber. The pieces are carefully heated with exclusion of air and then compressed into a uniform mass by intense hydraulic pressure. The softened amber being forced through holes in a metal plate. The product is extensively used for the production of cheap jewelry and articles for smoking. This pressed amber yields brilliant interference colors in polarized light. Amber has often been imitated by other resins like copal and cory gum, as well as by celluloid and even glass. Baltic amber is sometimes colored artificially, but also called true amber. Appearance: amber occurs in a range of different colors. As well as the usual yellow-orange-brown that is associated with the color amber, amber itself can range from a whitish color through a pale lemon yellow, to brown and almost black. Other uncommon colors include red amber, green amber, and even blue amber, which is rare and highly sought after. Yellow amber is a hard, translucent, yellow, orange, or brown fossil resin from evergreen trees. Known to the Iranians by the Pahlavi compound word karuba, which entered Arabic as kareba or kareba, it too was called amber in Europe. Found along the southern shore of the Baltic Sea, yellow amber reached the Middle East and Western Europe via trade. Its coastal acquisition may have been one reason yellow amber came to be designated by the same term as ambergris. Moreover, like ambergris, the resin could be burned as an incense. The resin's most popular use was, however, for ornamentation. Easily cut and polished, it could be transformed into beautiful jewelry. Much of the most highly prized amber is transparent, in contrast to the very common cloudy amber and opaque amber. Opaque amber contains numerous minute bubbles. This kind of amber is known as bony amber. Although all Dominican amber is fluorescent, the rarest Dominican amber is blue amber. It turns blue in natural sunlight and any other partially or wholly ultraviolet light source. In long-wave UV light it has a very strong reflection, almost white. Only about 100 kg is found per year, which makes it valuable and expensive. Sometimes amber retains the form of drops and stalactites, just as it exuded from the ducts and receptacles of the injured trees. It is thought that, in addition to exuding onto the surface of the tree, amber resin also originally flowed into hollow cavities or cracks within trees, thereby leading to the development of large lumps of amber of irregular form. Classification: amber can be classified into several forms. Most fundamentally, there are two types of plant resin with the potential for fossilization. Terpenoids, produced by conifers and angiosperms, consist of ring structures formed of isoprene units. Phenolic resins are today only produced by angiosperms, and tend to serve functional uses. The extinct Medullosans produced a third type of resin, which is often found as amber within their veins. The composition of resins is highly variable. Each species produces a unique blend of chemicals which can be identified by the use of pyrolysis or gas chromatography or mass spectrometry. The overall chemical and structural composition is used to divide ambers into 5 classes. There is also a separate classifications of amber gemstones, according to the way of production. Class I, this class is by far the most abundant. It comprises labdatrine carboxylic acids such as communic or ozic acids. It is further split into 3 subclasses. Classes IA and IB utilize regular labdanoid diterpenes, while IC uses enantiolabdanoids. IA includes succinate and glycite. Have a communic acid base. They also include much succinic acid. Baltic amber yields on dry distillation succinic acid, the proportion varying from about 3% to 8%, and being greatest in the pale opaque or bony varieties. The aromatic and irritating fumes emitted by burning amber are mainly due to this acid. Baltic amber is distinguished by its yield of succinic acid, hence the name succinate. Succinate has a hardness between 2 and 3, which is rather greater than that of many other fossil resins. Its specific gravity varies from 1.05 to 1.10. It can be distinguished from other ambers via IR spectroscopy due to a specific carbonyl absorption peak. IR spectroscopy can detect the relative age of an amber sample. Succinic acid may not be an original component of amber, but rather a degradation product of abiotic acid. Like Class E ambers, these are based on communic acid. However, they lack succinic acid. This class is mainly based on enantiolabdatinonic acids, such as ozic and zanzibaric acids. Its most familiar representative is Dominican amber. Dominican amber differentiates itself from Baltic amber by being mostly transparent and often containing a higher number of fossil inclusions. This has enabled a detailed reconstruction of the ecosystem of a long-vanished tropical forest. Resin from the extinct species Hymenaea protera is the source of Dominican amber and probably of most amber found in the tropics. It is not succinate, but retinite. Class II, these ambers are formed from resins with a sesquiterpenoid base, such as cadonine. Class III, these ambers are polystyrenes. Class IV is something of a wastebasket. Its ambers are not polymerized, but mainly consist of cedron-based sesquiterpenoids. Class V resins are considered to be produced by a pine or pine relative. They comprise a mixture of diterpenoid resins and N-alkyl compounds. Their type mineral is Highgate copelite. Classification of Baltic amber by the IAA. Natural Baltic amber, a gemstone which has undergone mechanical treatment only without any change to its natural properties. Modified Baltic amber, a gemstone subjected only to thermal or high-pressure treatment, which changed its physical properties, including the degree of transparency and color, or shaped under similar conditions out of one nugget, previously cut to the required size. Reconstructed Baltic amber, a gemstone made of Baltic amber pieces pressed in high temperature and under high pressure without additional components. Bonded Baltic amber, a gemstone consisting of 2 or more parts of natural, modified or reconstructed Baltic amber bonded together with the use of the smallest possible amount of a colorless binding agent necessary to join the pieces. Geological record: the oldest amber recovered dates to the Upper Carboniferous period. Its chemical composition makes it difficult to match the amber to its producers. It is most similar to the resins produced by flowering plants. However, there are no flowering plant fossils until the Cretaceous, and they were not common until the Upper Cretaceous. Amber becomes abundant long after the Carboniferous, in the early Cretaceous, 150 million years ago, when it is found in association with insects. The oldest amber with arthropod inclusions comes from the Levant, from Lebanon and Jordan. This amber, roughly 125 135 million years old, is considered of high scientific value, providing evidence of some of the oldest sampled ecosystems. In Lebanon, more than 450 outcrops of Lower Cretaceous amber were discovered by Dani Azar, a Lebanese paleontologist and entomologist. Among these outcrops, 20 have yielded biological inclusions comprising the oldest representatives of several recent families of terrestrial arthropods. Even older, Jurassic amber has been found recently in Lebanon as well. Many remarkable insects and spiders were recently discovered in the amber of Jordan, including the oldest zoropterans, chlorid beetles, eumnicoleid roaches, and chileid planthoppers. Baltic amber or succinate is found as irregular nodules in marine glauconitic sand, known as blue earth, occurring in the lower Oligocene strata of Sambia in Prussia. After 1945, this territory around Kar-Paragraph-Nigsburg was turned into Kaliningrad Oblast, Russia, where amber is now systematically mined. It appears, however, to have been partly derived from older Eocene deposits, and it occurs also as a derivative phase in later formations, such as glacial drift. Relics of an abundant flora occur as inclusions trapped within the amber while the resin was yet fresh, suggesting relations with the flora of Eastern Asia and the southern part of North America. Heinrich Gar paragraph ppet named the common amber-yielding pine of the Baltic forests Pinus succinita, but as the wood does not seem to differ from that of the existing genus, it has been also called Pinus succinifera. It is improbable, however, that the production of amber was limited to a single species. And indeed a large number of conifers belonging to different genera are represented in the amber flora. Paleontological significance: amber is a unique preservational mode, preserving otherwise unfossilizable parts of organisms. As such, it is helpful in the reconstruction of ecosystems as well as organisms. The chemical composition of the resin, however, is of limited utility in reconstructing the phylogenetic affinity of the resin producer. Amber sometimes contains animals or plant matter that became caught in the resin as it was secreted. Insects, spiders and even their webs, annelids, frogs, crustaceans, bacteria and amoebae, marine microfossils, wood, flowers and fruit, hair, feathers and other small organisms have been recovered in ambers dating to 130 million years ago. In August 2012, two mites preserved in amber were determined to be the oldest animals ever to have been found in the substance. The mites are 230 million years old and were discovered in northeastern Italy. Use: amber has been used since prehistory in the manufacture of jewelry and ornaments, and also in folk medicine. Amber also forms the flavoring for aquavit liquor. Amber has been used as an ingredient in perfumes. Jewelry: amber has been used since the Stone Age, from 13,000 years ago. Amber ornaments have been found in Mycenaean tombs and elsewhere across Europe. To this day it is used in the manufacture of smoking and glass-blowing mouthpieces. Amber's place in culture and tradition lends it a tourism value. Palanga Amber Museum is dedicated to the fossilized resin. Historic medicinal uses: amber has long been used in folk medicine for its purported healing properties. Amber and extracts were used from the time of Hippocrates in ancient Greece for a wide variety of treatments through the Middle Ages and up until the early 20th century. Scent of amber and amber perfumery: in ancient China it was customary to burn amber during large festivities. If amber is heated under the right conditions, oil of amber is produced, and in past times this was combined carefully with nitric acid to create artificial musky resin with a peculiar musky odor. Although when burned, amber does give off a characteristic pinewood fragrance, modern products, such as perfume, do not normally use actual amber. This is due to the fact that fossilized amber produces very little scent. In perfumery, scents referred to as amber are often created and patented to emulate the opulent golden warmth of the fossil. The modern name for amber is thought to come from the Arabic word, ambar, meaning ambergris. Ambergris is the waxy aromatic substance created in the intestines of sperm whales and was used in making perfumes both in ancient times as well as modern. The scent of amber was originally derived from emulating the scent of ambergris and or labdanum, but due to the endangered status of the sperm whale the scent of amber is now largely derived from labdanum. The term amber is loosely used to describe a scent that is warm, musky, rich and honey-like, and also somewhat oriental and earthy. It can be synthetically created or derived from natural resins. When derived from natural resins it is most often created out of labdanum. Benzoin is usually part of the recipe. Vanilla and cloves are sometimes used to enhance the aroma. Amber perfumes may be created using combinations of labdanum, benzoin resin, copal, vanilla, damara resin and or synthetic materials. See also, amber road, amber room, amylite, copal, list of types of amber, oil of amber, pearl, precious coral, references. External links: Farlang many full-text historical references on amber Theophrastus, George Frederick Hans, and special on Baltic amber. IPS publications on amber inclusions: International Paleoentomological Society, scientific articles on amber and its inclusions, Mineral on amber physical properties and mineralogical information, MINDAT amber image and locality information on amber, NY times 40 million-year-old extinct B in Dominican amber.